All right, this is a neat problem, and it's actually a theorem that we proved in class when I took a class on this. So I didn't have to do any work. Um, Although it is actually a pretty neat and fairly quick proof. I don't know, I like it. So suppose I is maximal. Let AB, we want to prove that I is prime, so we take two elements A, B, and R such that AB is in I and A is not in I. So we know, let's see here, I is maximal. Right. Um, AB is in I and A is not in I. And we want to prove for I to be prime, we must have that B is in I. So I claim B is in I. I'm not going to write that because that involves I, and I is the word I and the thing, the ideal I, whatever. So anyways, let I1, or we could call it I prime, whatever. Let's this be the I plus R times A. Now since R is commutative, I1 is an ideal. Let's verify this. Okay, so I1 plus RA. So let's see here. If you multiply something by, or if you add two things in I plus RA, then you just add the things in I and you add the things in RA, and so it's clearly closed under addition. As for multiplication, if you multiply it by R, then multiplying it by I on the left or right by an element R will keep you in I because I is an ideal. And if you multiply on the left or right by an element R, then what happens to big R times A? Well, the little r, because of commutativity, can get moved around to the left-hand side, so that's little r times big R times A, and then the little r gets absorbed in the big R because big R is closed under multiplication because it's a ring, and so there you go. It's an ideal. A is certainly in I1 because I is an ideal, so it contains 0, and R is a ring, so it contains 1, and so A is just the element 0 plus 1 times A, which is in I. And so, but also A is not in I, or it's in I1, but it's not in I, so it's in I1 set minus I. And I is maximal. And so it must be that I1 is all of R. So 1 is in I1, meaning there is some C in I and some R in R, such that 1 equals C plus RA. So multiplying by B, we get B is BC plus BRA. BC is, let's see here, B, let's see here. C is in I implies that BC is in I, and let's see here, we know that, what do we know? We know AB is in I implies that BRA, which is just by commutativity, ABR is in I. So B is the sum of two things in I, so B is in I. Hence, I is prime. And there we go. This is a nice, quick proof, and it involves a couple neat definitions, and so it's a nice problem. And we finished our proof.